Lesson 6.3, elimination by adding and subtracting. Our objective today is to solve a system of equations by the elimination method. So the elimination method is taking the two equations, you add or subtract, and one of the variables is eliminated. We're going to kind of do this in 2 days, but honestly, lesson 6.4 is a continuation of this. Today's elimination, the equations are completely ready for you to start the elimination. Tomorrow you have to do a little bit of work to get the elimination set up. The standards are Algebra 1, 2-1, 5-4, and 5-6. So this works for two equations that are written in standard form. That means ax plus by equals c. Yesterday, the method was best if one of the equations was already y equals or x equals. This method is better for standard form. Okay, what's going to happen is one set of coefficients are either going to be the same or they're going to be opposites. Coefficients being the numbers in front of your variables. If they're the same, you're going to subtract the two equations so the variable falls out. If they're different, you're going to add the equations so they fall out. I might even show you a trick about when they're the same because it's much easier to add the equations than to subtract. Either way, you want either the x's to fall out or the y's to fall out. So here's what I mean by coefficients being the same. If it's 5x in both of them, or opposite if one's 7x and one's negative 7x. Okay, so you're looking for the variables that have the same coefficient or exact opposites. All right, so let's look at example A. Example A, the system is this. 3x plus 4y equals 2, and 4x minus 4y equals 12. Okay, so we're looking for coefficients that have the same or opposite number, and I think you'll see that the y's would happen to be that they're opposites. So guess what you get to do? They're opposites. We're going to add that system just like this. 3x plus 4x, 7x. 4y minus 4y, gone, equals 14. Solve for x, divide by 7, x equals 2. We have half of our solution already done. So when I start my ordered pair, 2 is x. I just got to find y. Now honestly, it does not matter which one you go back to. You can just arbitrarily pick. Let's go into the top one. So that would be 3 times 2 plus 4y equals 2. I substituted x in place of that x. I substituted 2 in place of that x. So 6 plus 4y equals 2. Subtract 6. 4y equals negative 4. Divide by 4, y is negative 1. A lot quicker, huh? A lot quicker. You do have to do substitution from one side to the next, but that's going to be in any of them. That's going to be in any of them. Okay, questions about example A. All right, let's look at example B. Now it says 6x minus 2y equals 32, 4x minus 2y equals 18. I'm going to revise what I would normally say about this a little bit. I don't like the thought of subtracting because you know what? You're going to mess up signs. So here's what I'm going to tell you to do. Let's make it so that the y's are opposites. What could change a negative 2y into a positive 2y, Avery? Yeah, multiplied by negative, what? Negative Let's just go ahead and multiply that bottom one times -1. So my top one, go ahead and write 6x minus 2y equals 32. And basically the bottom one's going to change every sign, isn't it? -4x plus 2y, -18. Now some people might say, no, just subtract those. Well, it kind of ends up being the same thing, obviously, because we've just changed all those to the bottom. But when you subtract, and I just say, hey, take the top one minus the bottom one, it would be 6x minus 4x, wouldn't it? So we've kind of are doing the same thing. It's a more formal thing where you change all the signs so you don't forget the signs are changed. So this would be 2x. The y's fall out. It equals 14. Divide by 2, x is 7. So I have half of my solution done. It's 7 something. Now I would definitely go back to one of my original equations. Let's go to that one on top. 6 times 7 minus 2y equals 32. It really doesn't matter which one you use. You're going to get the same exact answer either way. So 42 minus 2y equals 32. Subtract 42 from each side. -2y equals -10. And divide by -2. So y is 5. So your solution is 7, 5. Questions about that? All right, example C. -x plus y equals 1. X plus y equals 11. Is that top one a good standard equation of a line? Is that good standard form? No, why not? What? Yeah, the A wouldn't be negative, but for some reason they're giving you the system like that. Yes?
I have a question for the y. Do you always want the top and the bottom y to be different?
It doesn't have to be y. It could be the x. You want one set, one or the other, x or y, to be different. So in this one, it's going to be the x's because they're already different. Today's elimination, they're already going to be ready for you to add or subtract, or basically add, because I want you to change the signs if you have to subtract. Okay? They're already going to be the same. Tomorrow, it'll be a little different. So if I put these together, if I add, these x's are going to fall out, and I would get 2y equals 12. Divide by 2, y equals 6. So half of my solution has y equaling 6. I'm going to go take this 6 and put it back right here. X plus 6 equals 11. Subtract 6, and my x is 5. Now I do want you to know they may not all come out to integers. It might be fractions to kind of make your life a little more fun. It's just, they're fractions. It is what it is, okay? Let's look at this example D. 6x minus 2y equals 1. -10x plus 2y equals -5. When I combine those together, my y's would definitely fall out. And 6x minus 10x would be -4x. And 1 minus 5 would be -4. Divide both sides by -4, and x would be 1. So that is half of my solution, so 1 goes in place of x. I'm going to go plug it in at the top. 6 times 1 minus 2y equals 1. 6 minus 2y equals 1. Subtract 6 from both sides. -2y equals -5. If I divide by -2, here's one of those instances, it's going to be +5 halves because it's a negative over a negative. That would result in a positive. So my ordered pair would be 1 5/2. Just leave the fraction, okay? Just leave the fraction. Now I need to add a word problem to this, okay? I need to add a word problem at the end here. Are there any questions about any of the ones so far? Yes?
If there's one that's, if they're both like positive, like both x's are positive, the same, what would we do then?
If they're both the same, then I would recommend taking one of the equations and multiplying by -1. In other words, changing all the signs through that equation. And then go back and add. Okay? Ben?
What if it was like x plus y equals 1 and then the second one was x plus y equals 1?
Then you would change both signs. You'd change all signs in the second one. And I think the x's and y's would fall out. And then you'd have 0 equaling a number. So if 0 equals a number, what would you say for your answer? No solution. So it could happen that the variables fall out on these. And just remember the rule. If the variables fall out and the numbers left are equal, then it's infinitely many solutions. If the letters fall out and the numbers left aren't equal, you'd say empty set or no solution. Okay, I definitely want to add a word problem, so please write this. Okay? Here it is. The sum of two numbers is 18. Their difference is 2. Find the two numbers. The sum of two numbers is 18. Their difference is 2. Find the two numbers. So I'm going to let the two numbers be x and y. Okay, so I'm going to say let x be the first number and let y be the second number. I'm not doing a very good job writing that, am I? Okay, second number. Okay, so if it says the sum of their two numbers is 18, I would say x plus y equals 18. Their difference is 2. X minus y is 2. What do you think about that? Pretty easy, isn't it? Because it's exactly what we were just doing. Add these two together. 2x, the y's fall out, it equals 20. Divide by 2, and the first number is 10. The second number, 10 plus y equals 18. Subtract 10, y is 8. So find the two numbers. So I would say the two numbers are 10 and 8. Can you do that? They might have a few other word problems where you write the equations and they're going to turn out to be very similar to what we just had. Very similar.